Greetings to you. Welcome to Physics with Ben. Don't forget to subscribe and share this video. Also, click on the notification bell to get accurate notification anytime I upload a content. This is a video series on GCE preparation this year, alternative to practicals. Click in the description box below and you will get all the video series. Wish you success in this exam. In today's video, I want to perform an experiment on mechanics, knife edge. Yes, you heard me right. So, let's go straight to the point. This is something you may expect on the day of your exam. If you see something like this, how do you go about it? Very simple. Follow me along, let's read. You may screenshot this or zoom this page and then read it out yourself. So, let's read along. The figure above shows a meter rule of mass M balanced horizontally on a knife edge at a point K by suspending a 100-gram mass at a point A and another 100-gram mass at B. The initial distances L and D are then measured. The experiment is repeated 5 more times, keeping the position of the mass at A constant while varying the positions of B and K to obtain the corresponding values of L and D. Figure 1A and 1B. Figure 1A and 1B. Figure 1A and 1B shows the values of L subscript I and D subscript I respectively, where I is equal to 1, 2, 3, 5, and 6. Instruction number 1. Determine and record the values of L subscript I and the corresponding values of D subscript I. Tabulate your readings. Plot a graph of D on the vertical axis and the real values of L on the horizontal axis, starting both axes from the origin 0, 0. 3. Determine the slope S of the graph and the intercept C on the D axis. If the relationship between S and M is given as S is equal to 100 divided by 200 plus M, obtain a value for M. State 2 precautions you would take if you were to perform this experiment in the laboratory. BI. Define the center of gravity of a body. At this point, I believe you may screenshot and we're going to make use of BII later in this video. So, let's go straight to the point. In the other video series, I have taught you how to generate your table of values, and I've told you the importance of your table of values. That the table of values carries more marks, and you won't afford to toy with this. So, without wasting much time, let's begin. Pick up your pen and write with me. You may write table of values, or you may write observations. Just choose the term you are comfortable with. Then I told you again that this I simply means the number of times the experiment is to be performed. So in this case, we have 1, 2, 3, 4, 5, 6. That is the serial number. So we'll write here on the composite table I. Then we'll write down 1, 2, 3, 4, 5, and 6. You pick up your ruler and you draw a straight line. Good. The next parameter in the table of values is Li, the distance from this point to this point, Li. So we record L. Don't forget the Li simply means L1, L2, L3, L4, L5, L6. So we write Li slash Cm. You draw a straight line. Now, don't forget that there's an instruction on this diagram. Please, on the D-day of your exam, pay accurate attention to all the instructions. Scale. 1 cm represents 5 cm in figure A. It means that whatever you get here, you times it by 5. We call it Li convert. We write Li con, meaning convert. Get it? Slash cm. If you don't do this, you won't get your full marks. Draw a straight line. Good. The next parameter is di. d1, d2, d3, d4, d5, d6. Then you write di slash cm. So we are done with our composite table. Sorry, this line is longer. We are done with our composite table. The next thing is to start reading the values. Good. Now, I want to explain something here quickly before we start reading. You see this? You see this broken line? It's 0 to this point. How do you read this? It means that we are going to start our reading placing the ruler, the 1 cm mark at 47. So in this case, you read from here to here. We have gotten, we have one as the reading. So 1 plus 47 is what you're going to record. Get it? Good. So let's begin. So we start with L. So this is L1. This is L1. Good. So we place this at the 0 cm mark here. And this is the value corresponding with L1, this point here, this point, particular point here. So we have 1, 2, 2.5, 0.6, 0.7. Let's look at it again. This is 1, 2, 2.5, 0.6, 0.7. So we have 2.7. So record here 2.70. So, but the scale said 1 cm represents 5 cm in figure D. So we're going to times this by 5 to put the record here. So if you do that, 2.7 times 5, we're going to have 13.5. So we have 13.50. That's it. Now the next thing is we'll go for D1. D1 is measured putting the 1 mark, the 0 mark at 47 cm. So we place, and then at the end you add what you get to 47. So we place this here. Good. You see that? The alignment. So on my reading here, this is your D1. Your D1 we have, this is 1. Yes, we have 1. So 47 plus 1, we have 48.0. So record 48.0. I'll do it for the second time. Let's go for L2. So for L2 we have the reading as follows. This is 1, this is 2, this is 3. 3.5, 0.6, 0.7, 3.75. Yes, 3.75. So record 3.75. So 3.75 times 5. We have 3.75 times 5. That will give us 18.75. Let's go to D2, this point. So our D2 is recorded as follows. So we have 1, we have 2, 2.5, 0.6, 0.7, 0.8, 2.8 plus 47, meaning 49.8. 49.8, 2.8 plus 47. Yeah, 49.8. Record 49.8. Let's record to 2dp, everything to 2dp. So we'll put another 0 here, another 0 here. So we're going to repeat this procedure and finish all the table of values. And we are done with the table of values. This is where the bulk of your mark lies. Screenshot. Good. The next line of action is we are done with instruction number 1. Number 2, plot a graph of D on the vertical axis with the real values. Take note, real values of L. It means we are going to work with this. These are the real values of L. The graph of this on the Y and the graph of this on X. Take notes. So write that a graph of D versus what? Li. So this is scale on D and then on what? Li. So just want to do this for convenience sake. You look at this, there's an increase trend. I've been predicting all my graphs before I plot them. No, this will give you a straight line graph, increase. As the values of L are increasing down, the values of Di are increasing down. So when you plot a graph, you get this or this, passing through the origin, and then something like this. In this case, the examiners asked us to find the intercepts on the D axis. The D is cm, and then the Li in cm. It means that this is the graph we are going to find. A graph of y is equal to mx plus c. mx plus c. This is the type of graph we are going to find, not this and this. So keep that at the back of your mind. So the next thing I want us to do right now is to choose a suitable scale. Here the highest value is 56. On the D is 56. So let's look at this. There are how many boxes here? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. So we can say that let 2 cm represent 10 units. That will give us 60. See that? This is 10, 20, 30, 40, 50, 60. So we write that on this axis, let 2 cm be equals to what? 2 units. Here the highest value is 7. So let's spread our graph. We are considering from this point to this point. Can 2 cm give us up to 10? Yes. Then this is 2, 4, 6, 8, 10. So we can say that let 2 cm be equals to what? Sorry, this is 10 units. Equals to 10 units here. And here this is equals to what? 2 units. We are done defining our slope. The next thing is to plot our graph. So they asked us to start everything from the origin. So since we're going to use the whole of this graph, draw a straight line here. It's your horizontal line. Good. And then another line up here as your vertical line, the line for the d-axis. Then you put an arrow here, then you write d/cn. Then you put another arrow down here, you write l/cm. So this is 10, this is 0, 0, this is 10, another 2 cm, this is 20, and then 60. On the horizontal axis, we say 2 cm to 2 cm 2 units. It means this is 2, this is 4, this is 6, this is 8, and this is 10. Good. The next thing is to plot the graph. But before we do that, don't forget I gave you a trick on how to plot graph. You're going to find the value for each small box. The value for each small box is very, very important in this type of graph. So how are we going to do it? So we're going to say 10 divided by 20. 10 divided by 20. That will give us 0.5. It means that the value for each small box here is 0.5. 2 divided by 20. 2 divided by 20. 0.1. The value for each small box here is 0.1. Good. Now we are going to divide everything here, everything on the d-axis by 0.5. Everything here on the l-axis by 0.1. That is everything here by 0.5 and everything here by 0.1. You get it? Good. Let's move on. So we are going to divide everything by 0.5 to get the exact value on the d-axis. Everything by 0.1 to get the exact value on the l-axis, the horizontal axis. So let's plot the first point. When 2.7, where do we get 2.7 on this axis? Just say 2.7 divided by 0.1. That will give you 27. It means that we are going to count 27 small boxes to give us 2.7. No stress. Good. So this is the l-axis. Let's count. This is 10. This is 10, 20. Then 1, 2, 3, 4, 5, 6, 7. This is 27. Good. So you trace 27 where it touches 48. Where do we get our 48? Very simple. 48 divided by 0.5. 96. It means we have to count 96 small boxes to get to 48. However, this is 10. This is 10, 20, 30, 40, 50, 60, 70, 80, 90. Right? Then let's count 96. This is 1, 2, 3, 4, 5, 6. That's it. So where this point and this point intersect, that is the first point we are going to plot. So if we place it up here, then we trace it. You have to use your ruler so that you don't make mistakes. Good. Then this point is right here. So just trace it with your pen. Sorry, you don't use pen in plotting graph. I'm doing that because I'm a teacher. This is the point. Good. This is the point. We have plotted the first point. And so we are going to repeat this for all the values. Get it? Let's move on. Okay, I feel like plotting the second value before I fast forward this video. Oh, okay, let me just plot the second value for the sake of emphasis. Now we are done plotting this point. Let's plot the second point. 3.75. Just divide by 0.1. So we say that 3.75 divided by 0.1. You get it? We have 37.5. Round it up, that is 38. It means I'm going to count 38 small boxes on the horizontal axis. So let's do it again. This is 10, 20, 30. Let's count 8. 1, 2, 3, 4, 5, 6, 7, 8. 38 small boxes will give you exactly 3.75. So the next one is 49.8. We don't want to approximate, let's do it the right way. So have 49.8 divided by 0.5 divided by 0.5. That will give us 99.6. That is 100. Good. So let's count 100 small boxes. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 100 small boxes is exactly on the 50th cm. Good. On the 50th cm. So we place this ruler here and do what we did the first time so that you don't miss out the line. Just put it exactly what I'm doing here. This is the point I'm talking about. Good. Where is 50? Look at 50 here. So this is the point. This is the point. So we are done plotting 2 points. So we are going to repeat what you just see me doing for the remaining values. Stay tuned. And we are done with the table of values. Yes. So we have 1, 2, 3, 4, 5, 6 points against 1, 2, 3, 4, 5, 6. So this is the table of values. The graph I predicted is here. I predicted this particular graph here. Look at the graph we're going to have. Intercepts on D axis. The examiners were correct. So now let's draw the line of best fit. this line should be okay. So we draw this line like this once. Good. This is the line of best fit. This is your slope. And this is your line of best fit. So the intercept is on this point. We'll write it change in C. To quickly get that value, we say that 0.5 times 10, 20, 30, 40, 50, 60, 70, 80. 1, 2, 3, 4, 5, 6 times 86. So 0.5 times 86 will give us 43. So our intercept is what? 43 cm. So let's write it quickly before we forget. Our intercept is what? 43 cm. We'll record that later. So let's find the slope of the graph. To find the slope of the graph, we have to choose this point. Let's choose this point. Let's choose this point. We choose this point. We choose this point. We choose this point. When you have a big triangle, you have less error in the experiment. So we draw a line here. Good. And then extend it down as broken lines. Dot, 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 dot. Here, something like this. Down to this point. Yeah, good. Next up, we join this line from this point to this point. Good. Then some broken lines like this. Next, we extend these broken lines to this point. Good. Next up, we extend these broken lines down. So your graph will look like this, something like this. Good. So here is your change in T, and here is your change in L. Here is your D2, and here is your D1. Here, this point is your, we put it down here. This point here is your L2, and this point here is your L1. Something like this. Give me a screenshot. Good. So the next thing is to calculate the slope, which is actually question determine the slope right here, right now. That is I. I'll plot the graph. So answering question I now. So the slope of the graph is giving us change in D divided by change in L. This means D2 minus D1 divided by L2 minus what? L1. From the graph, D2 is this value, that is 60. So right, this is the same thing as 60 minus, what is our D1? Our D1 is slightly above here. So let's count. This is our D1. So we say, how do we get that value? Simple. 0.5 times, this is 10, 20, 10, 20, 30, 40, 50, 60, 70, 80, 10, 20, 30, 40, 50, 60, 70, 80, 90. Yes, 90. So 0.5 times 90 will give us that value. 0.5 times 90 will give us 45. So write 60 minus 45 divided by this value traced down here. Look at it. The value for each small box here was 0.1. So this value is at what? Let's count. This is 10, 20, 30, 40, 50, 60, 70, 80, 90. 90 as well. So we say that 0.1 times 90, that will give us 9. So write that 9 minus, here is simply 1. 9 minus 1. Good. So our slope is giving us 60 minus 45, that will give you 15. And 9 minus 1, that will give you 8. And 15 by 8 will give you 0.1875. Our slope has no SI because CM cancels out CM, so this is the value for the slope. So the next thing we are going to do from this question is they ask us to determine the intercept C on the horizontal on the D axis. So determine the intercept C. So here the intercept C, change in C, is given to be, as we record it from the graph. Remember? Good. So the intercept C is given as 43.00 cm. That's it. The next question they ask us to calculate here, the examiners ask us to, that is question IV, that if S is given to be 100 divided by 200 plus M, you should find M. You should obtain a value for M. Yes, if this is equal to this, so what we're going to do here, just transfer this value to this place. So we cross multiply, just put it in the bracket. So this is the same thing as this implies that 100 is equals to, the value for S is 0.1875. So right, okay, let's do it. So S into 200 plus M. Good. If you open the brackets, you have, let's substitute right now. So we have this value times 200, that is, we have 0.1875 times 200, then plus 0.1875 M. Good. Then you have 100 on this side. So this implies that you have 100 is equal to this and this, you have 37.5 plus 0.1875 M. So you collect like terms. So you have 0.1875 M is equals to 100 minus 37.5. So our m is the same thing as 100 minus 37.5. That will give us 62.5 divided by 0.1875. Do that correctly. We have 62.5 divided by 0.1875. And that will give us 333.3. What is the value for m? What is the unit for m? So m has no units. So this is the value for m according to this particular experiment. So the next thing they ask us to do is to VI let's do it here. V states, they ask us state two precautions. State two precautions you would take if you were to perform this experiment in the laboratory. Yes, you don't say I avoided error due to parallax when taking reading on the meter rule. Here you just state two. You say I would have avoided error due to parallax when taking reading on the meter rule. I would have ensured the masses were not touching the table. Let's stop there. Or I would have avoided air interference by closing all the air source. These are the three precautions you choose two from. So we are done with the precautions. The next thing that asks us to find VI, the center of gravity of a body. VI. The center of gravity of a body is simply a point where the entire mass or weight of the body is concentrated. And then the next question they ask us is this. Let's calculate. So a 120 gram mass is suspended 15 cm from the zero end of a uniform meter rule. If the meter rule is balanced horizontally, determine the mass of the rule or the meter rule, given that the pivot is 20 cm from the center of gravity of the ruler. Very simple. Just sketch. Screenshot. So one important thing in that question is that it's a uniform meter rule, meaning 100 cm. So we're going to do scale drawing from 0 to 10 as our 100 cm meter rule. Good. So this is our meter rule. And then the meter rule is supposed to balance, the center of gravity of the meter rule is supposed to be at the 50 cm mark. So 5 here, that is CG. Center of gravity is supposed to be at 5 cm mark here. Scale drawing 1 to 10. Good. Now, they said that the meter rule was pivoted. The meter rule was pivoted at the 20 cm mark. Was pivoted at the 20 cm mark. So let's choose 2 to be the 20 cm mark. 2 to be the point of pivot. This is the point, this is where it was pivoted. Good. And then it was a mass of 120 grams was hung at 15 cm mark. Let's choose anywhere here to be our 15 cm mark. Let's assume this place is our 15 cm mark. Good. This place is our 15 cm mark. And so the mass of what? A mass of 120 gram at the 15 cm mark. And then you recall that from this 0 point to this 100 cm, from this point to the center of gravity is your 50 cm mark. and that and then the mass of the ruler is supposed, the weight of the mass of the ruler is supposed to be at the center of gravity here. So this is what we are going to look for, the mass of the ruler. And so another instruction here, from this point to this point of pivot is 20 cm. So how, and then from this point to this point is 15 cm. So how do we get this point? This is what we're interested in, this point and then this point. So this point is simply 50 minus 20 will give us 30 cm, and then this point is simply 20 minus 15 will give us 5 cm. So from the principle of moment, clockwise moment is equal to anti-clockwise moment. So this implies that the moment here is simply 120 times 5, so we'll have 120 times 5 is equals to 30 times the mass of the ruler. We divide both sides by 30, both sides by 30, so that our m is equals to we have 6 divided by 30. This go, and then 60 divided by 3, that will give us 20. So we'll have 20 gram as the mass of the ruler. Therefore, the mass of the ruler is what? 20 gram. Good. To this, we have come to the end of this video. This video is very, very comprehensive. We started here, and then we got to this point. We plotted our graph, and then we looked for the slope, now the deduction, and then here we are. Don't forget to like this video, share this video, and subscribe to Physics with Ben. Wish you success in your exam. God bless you. Bye-bye.